Hi and a very good evening to you all. So we are going to start pharmacology review sessions. Now what is meant by review sessions? See, we had detailed lectures on pharmacology where every point, every concepts were discussed in detail. Now this is going to be review sessions. Now this is going to help the crash course students well and good. So those who have done with comprehensive course, you have seen all those detailed lectures. Now the time is very limited. We have got 3 months in front of us, isn't it, for the exam. So what are we going to do is that we're going to review the most important points of each and every chapter for each and every subject, so that we can quickly finish off a particular portion, okay, and that too the key areas of a particular chapter. Okay, now how is the key areas being selected? What we have done is we have reviewed the last 5 years question paper. Okay, and the topics are selected based on the last 5 years question paper, and from there, so that is arranged in a very topic wise manner, and from there whatever topics has been asked in the last 5 years is selected, and that topic is going to be discussed for the last 25 years. Okay, for example, you can see the mechanism of action of antibiotics. So whatever is being asked so far in AIPG, in AIMS, in PGI, in the last 25 years is being discussed. So how did we select the mechanism of action of antibiotics, the topic? That is because it was asked in the last 5 years. So like that, we'll be focusing on each and every key areas, and the most crucial points are going to be discussed. So it's going to help those students who are preparing late. One. Second, those who have already prepared, already done with all the lectures, it will be a review session for you all. Okay, so let us start. So it's a very important chapter in pharmacology, that is the antibiotics. Now if you see the topic mechanism of action of antibiotics, there are different ways by which antibiotics act. One is by inhibiting cell wall synthesis, the other is by inhibiting protein synthesis, also known as translation. Okay, there is transcription and translation, isn't it, in biochemistry. So in that translation, drugs inhibiting protein synthesis, which is translation, drugs affecting nucleic acids, the DNA, RNA, drugs are acting on the cell membrane. So this is something which is very recently being asked for you, so it's included. Okay, now drugs inhibiting cell wall synthesis, you all know penicillin is a key, okay, in which comes beta-lactam antibiotics, very important. Then you have got vancomycin and bacitracin. So in our lectures, we have discussed van, bus, cycle, like that. So similarly, beta-lactams. So these are the topics asked for you, very key areas. Beta examples, very important, which are the drugs acting by inhibiting cell wall synthesis. So it includes beta-lactam antibiotics, van and bus, vancomycin and bacitracin. Now, beta-lactam antibiotics all are familiar with, but yes, two things, very important. Which are the enzymes? So there are certain enzymes in cell wall synthesis. So this antibiotic specifically inhibit those enzymes. Okay, so that is what we are going to see. A very important enzyme inhibited by the beta-lactam antibiotics is known as transpeptidase. So transpeptidase, peptidoglycan is a cell wall. So the one which is doing the that is cross-linking the connecting the peptidoglycan. These are transpeptidase. Okay, the other name for transpeptidase is penicillin binding protein, because penicillin binds here and inhibits the cell wall synthesis of the bacteria. So transpeptidase. Okay, it's a very important question asked. Then examples of these drugs, beta-lactam antibiotics, you all know, one is definitely penicillin, other is cephalosporins. Then you have got carbapenems and monobactams. Okay, those who are not familiar, learn this carbapenems and monobactams. Now see, those who have not prepared their notes during their theory lectures, they can prepare it now. And those who are in the crash course also, you have to prepare it now, because pharmacology has to be written and learned. You have to write pharmacology and learn, otherwise it will just vanish. Okay, you write once carbapenem, it will stay there. Okay, and revision also becomes very easy. Now in cephalosporin, they have specifically asked two drugs. One is cefamycin. Now this is a antibiotic which is related to cephalosporins. You can't call it as a very much cephalosporin, but it's related to. Name says cefamycin. Okay, then cefepime, you know this. This is basically what? fourth generation. We have discussed different generation of cephalosporins. So this is cefepime, which is a fourth generation. These are the two questions asked based on the mechanism of action, cefamycin and cefepime. Okay, and even carbapenems, monobactams, everything is asked. And here are the cephalosporin, cefamycin and cefepime is asked. Now, vancomycin, what you have to know is enzyme inhibited here is transglycolase. So this is basically what? Transpeptidase, peptidoglycan related. Now this is glycolase, sugar. What it does is it assembles a sugar backbone. Okay, just imagine backbone. This peptidoglycan, behind that there is some sugar. Okay, so that connection of that sugar to the peptidoglycan. Okay, you don't need to remember all these mechanisms and all. I'm just connecting that transglycolase so that it stays there in your mind. Okay, so that is basically the sugar backbone is N-acetyl glucosamine and N-acetylmuramic acid is also there. So it connects that. Okay, so yes, to peptidoglycan. It just connects this sugar into the peptidoglycan. Here, the transpeptide is connecting to peptidoglycan. So that's the penicillin or beta-lactam in general. And this is vancomycin, which is transglycolase. Okay, then another drug is bacitracin. We are going to review this in cell membrane also. This is going to act by two mechanisms. One is definitely inhibiting cell wall synthesis. Now, other group of drugs inhibiting protein synthesis. Unlike our detailed lecture, I am not reviewing the points. Okay, so that this lecture gets finished as soon as possible. Okay, I want to keep it as much as possible into 20 minutes. Okay, now drugs inhibiting protein synthesis, also there is no motivational points here. Okay, again in our detailed lecture we discuss, we give motivations, everything, but now here this is a review lecture, 20 minutes lecture. Okay, so drugs inhibiting protein synthesis, yeah, you are very familiar with these drugs: aminoglycosides, tetracycline, chloramphenicol. Okay, macrolides. So everything people confuses aminoglycosides and macrolides. So macrolides, and which is very much related to lincosamides. We'll discuss the examples. Then there is linazolides. Okay, so lincosamides, linazolides. These are the confusing areas. Aminoglycosides, macrolides. Remaining other two, tetracycline and chloramphenicol. You are very familiar with these drugs. Now, write it. Aminoglycosides, which are the drugs, very, very important. There are lots of drugs there in aminoglycosides, but a question asked, what is the mechanism by which gentamicin acts? Okay, so gentamicin, don't confuse it with vancomycin because it's a cell wall synthesis inhibitor. Gentamicin is an aminoglycoside. Vancomycin is it's a something related to cell wall synthesis inhibitor or something related to beta-lactam. So don't confuse gentamicin with vancomycin. Gentamicin, remember. Tetracycline, again inhibiting protein synthesis. No question has been asked related to this mechanism of action on all this, but what has been asked is macrolides and lincosamides. So macrolides, how you remember is the drugs there, erythromycin. So again, gentamicin, erythromycin. How you remember? I tell the students is that those who know remember this. Macro means big. Just imagine a big ball, macrolide. So what we do to the ball? You throw the ball. Throw mycin. So all those thromycins, erythromycin, azithromycin, all those thromycins are macrolides. Example asked was erythromycin, any thromycin. And then gentamicin is aminoglycoside. Vancomycin is, don't confuse there. Lincosamides, the drugs you have to note here is, one is clindamycin. So don't confuse chloramphenicol with clindamycin. This is chloramphenicol. Clindamycin is a lincosamide. Understandably, lincomycin is a lincosamide. Okay. So now, finally, linazolide also been asked. The mechanism by which linazolide acts is drugs, that is the drug which inhibits the protein synthesis, or you can call it as the translation. Now finally, or before, not finally, drugs affecting nucleic acid metabolism. So it can either act on DNA or RNA. So those, I'm not going into details of that. DNA synthesis, it's a biochemistry topic, but here there is a very important enzyme in the bacteria called DNA gyrase. Some antibiotics inhibit this DNA gyrase. The examples is very important question asked, quinolones. Okay, quinolones. So you have to remember that quinolones. So quinolones act by what mechanism? Gyrase, DNA gyrase inhibitor. Now DNA polymerase inhibitor, a very important drug is rifampicin. DNA polymerase. Okay, rifampicin, which is an anti-tubercular drug. Now, drugs destroying DNA, you all know this. Example, destroying the DNA, which is metronidazole. You commonly, whenever you do an impaction or difficult extraction, you prescribe metronidazole. Another question asked is on nitrofurantoin. So, which of the following mechanism by which nitrofurantoin acts? Is by destroying the DNA. So, metronidazole and nitrofurantoins. All these are acting on the nucleic acids, which is DNA or RNA. Okay. Finally, drugs acting on cell membranes. Now, you know bacteria has got a cell wall. Inside that is a cell membrane. So, there are some drugs which act on the cell wall, which we studied, beta-lactams. Now, on the cell membrane, the inner part of it. So, the mechanism of action by which they act is they create holes in the cell membrane. Okay, they create holes in the cell membrane, makes holes, that is, makes it leaky. Examples has been asked. That's very, very important. How you can remember is ABCP. Okay, ABCP. A for antifungal drugs. Now, this is again not directly your antibacterial or antibiotics. Okay, but it's antimicrobials. Yes. Nystatin, amphotericin B. Both are antifungals. We'll come to antifungals later on, but please note there is two drugs, nystatin and amphotericin B. Now, B for, so that is B for next one. Bacitracin. I told you, bacitracin acts by two mechanisms. One is cell wall synthesis inhibitor, second is acting on the cell membrane. So remember, this is one question asked. Okay, that is also inhibits cell wall synthesis. Okay, now C for colistin or polymyxin E. Okay, there is polymyxin B and polymyxin E. So next is polymyxin B. Okay, so there is polymyxin E and polymyxin B. Both has been asked. Other name for polymyxin E is colistin. Okay, colistin. And please note that this is important to note, the polymyxin B and polymyxin E, these are anti-pseudomonal drugs. Okay, have you heard of anti-pseudomonal penicillin, carbapenicillin? Yes. Similarly, these are not penicillins, but these are anti-pseudomonal drugs. Just a point to note. Okay, so antifungals, nystatin, amphotericin B, bacitracin, polymyxin E, polymyxin B. Okay, polymyxin E, they can also put colistin. Okay, they can also ask as colistin. These are colistin, sorry. These are anti-pseudomonal. So again, it's very important to note these mechanisms. Okay, now that is all about the mechanism. Now, type of action. The type of action of antibiotics, which is either, this is again a question asked for you, bacteriostatic, or they can be bactericidal. Static means stops the growth. Cidal means kill. Okay, kill the bacteria. So let's see the details of bacteriostatic. Now again, those just divided for easy learning. Those bacteriostatic drugs which are protein synthesis inhibitors, those which are affecting the metabolism, those affecting the DNA, like that. So we have already studied protein synthesis inhibitors. So among that, they've asked, the question is MLT, remember it as MLT course, that is those antibiotics which are bacteriostatic and protein synthesis inhibitor, remember as MLT course. Okay, next here, related to MLT course, so dedicated everywhere. So MLT course people, MLT means what? Medical lab technology, that is a course for lab technicians. So they are so dedicated everywhere, but then all of a sudden some patient comes and says, no, they are not. Okay, in fact they are. But just to remember, so this is how you have to remember. Protein synthesis is MLT course, drugs affecting metabolism, so dedicated everywhere, drugs affecting DNA, no. So what is M? We have already studied this, macrolides, thromycins. Okay, then we have already studied linezolid and lincosamides. Okay, T also we have studied, that is tetracyclines, and C for chloramphenicol. All this we studied, just remember this MLT course, protein synthesis inhibitor. So dedicated, now those are the drugs which are affecting the metabolism, okay, of like folic acid synthesis and all those. I'm not going into details of that, but just note sulfonamides, one drug there. D for dapsone. Now dapsone is a drug which is used in leprosy. Okay, it's a drug affecting metabolism, which is a bacteriostatic drug. Finally, everywhere, very important, ethambutol. Okay, a drug which is used for the tuberculosis. Okay, ethambutol. So yes, sulfonamide, dapsone and ethambutol, which are bacteriostatic. Now, it is, it is drugs affecting DNA, that is nitrofurantoins, and yes, one more, which is novobiocil. Okay, NN. Okay, nitrofurantoin, novobiocil. So that was about bacteriostatic drug. Now bactericidal, that is killing the bacteria. So here you have to note that the drugs affecting cell wall synthesis, all of them are CIDL because we have not seen them here, isn't it? So all the drugs which affecting the cell wall synthesis are CIDL. Okay, now yeah, all are CIDL. Okay, beta-lactam, cephalosporin, all those are CIDL antibiotics. Okay, now vancomycin, bacitracin, all. Okay, now protein synthesis inhibitors, we studied one group which is basically majorly these are static MLT codes, but one which is aminoglycosides, okay, which is streptomycin or those other than thromycin, gentamicin we studied. They are protein synthesis inhibitors which are CIDL. Okay, then drugs affecting DNA, you know this, metronidazole and quinolones. So drugs affecting DNA which is no is there, and here metronidazole and quinolones. And we studied drugs affecting membrane synthesis, yeah, ABCP, isn't it? So amphotericin B, colistin, polymyxin E, polymyxin B, you studied this, just note. And yes, we studied one of the anti-tubercular drug is static. Okay, what that is ethambutol is static. All other are CIDL. All anti-tubercular drugs except ethambutol is bactericidal. We'll study this more. These are the drugs: INH, rifampicin, pyrazinamide. Okay, so yes, we'll study this in detail, but please note this. So hopefully you have written the notes there. Now finally, we are going to say a little bit more on bactericidal drugs, the concept of CDK and TDK, that is concentration dependent killing, time dependent killing. There has been question examples asked for this book. Now before understanding them, you have to understand two very important concepts, which is MBC and MIC, minimum bactericidal concentration, minimum inhibitory concentration. There is a concentration of drug, the minimum concentration of drug required for bactericidal action, minimum concentration of drug for inhibitory action. Okay, so now that is the minimum concentration of the drug required to kill 99.9% bacteria, minimum concentration required. Okay. MIC means the minimum concentration of the drug required for preventing the visible growth of the bacteria, not killing, preventing the visible growth of the bacteria. So once you understand that, we'll come to the concentration dependent killing and time dependent killing. So concentration, basically in simple terms, concentration dependent killing is what? If the concentration is high, it will kill. Time dependent killing, if that particular drug is kept for this much time, it will kill. Okay, so concentration dependent killing is basically, that is, the killing effect of a drug is high only if the ratio of peak concentration by MIC is more. So the peak concentration with the concentration which is highest concentration. The peak concentration divided by minimum inhibitory concentration is high. Means, okay, I'll just give you the next, which is more simplified version. That is, when the peak concentration of the drug is much higher, peak concentration, that is a total concentration higher than MIC. That is, MIC means what? What is needed to stop the bacteria from growth? Inhibitory concentration. So if the peak concentration is more, yes, it is going to be a yes. It's called a concentration dependent killing. So basically, what is peak concentration meaning? Nothing but concentration dependent killing. Okay, so that is more. A drug is more likely to kill the bacteria effectively. Okay, if a higher peak concentration is there compared to the MIC. Okay, minimum inhibitory, the minimum needed, the more than minimum needed, if there is, just simply understand like this, if more than the minimum needed is there, it will kill the bacteria. Okay, so that is there. Now basically concentration dependent killing, what is more important as examples. Okay, but now before that, I'll give you the mnemonics. The time dependent killing, that is antimicrobial action here, depends upon the length of time the concentration is above MIC. It's the length of time. The other one was concentration. Okay, so it's basically simple. Now here the examples you have to remember is big one. So basically how you remember is always find big van to kill the bacteria. Okay, bactericidal. Okay, so always find a big van to kill the bacteria. Now, examples are what has been asked. Always is aminoglycosides. Okay, please note, it's streptomycin. Okay, all those mycin. Gentamicin is another aminoglycoside asked. This is streptomycin, which was asked question. So the question was all of the following kills by, or I would say, okay, which of the following drugs kills by concentration dependent killing? The answer was streptomycin. They gave other options also. And please note, it's aminoglycosides and not macrolides. Don't confuse. Macrolide means thromycins. This is streptomycin. Okay, don't confuse. So then always find is fluoroquinolones. Okay, fluoroquinolones. Now big van, which is basically time dependent killing. Big is beta lactam and van is vancomycin. Related, isn't it? Big van and always find. So always find is aminoglycosides and fluoroquinolones. So that will be the end of today's session. Now we will have to discuss some other concepts as well as some key antibiotics individually, okay, based on the recent questions again.